Hello, what? It's November the 8th. Alright, let's do it. Minimum array and you're given two integers, n and x. You have to construct an array of positive integers, nums of size n, where for every position, nums I plus 1 is greater than nums I, and the result of the bitwise AND operation between all elements of nums is x. Return the minimum possible value of nums n minus 1. You have to construct an array of positive integers, nums of size n, where it's increasing array, right? It's increasing array. And the result of the bitwise operation AND between every element of nums become x, and return the minimum possible, which is just try to create the least possible array. For example, n equal to 3, so we have 3 values, and x is 4. 4 is 1, 0, 0, right? So we need these 3 to come up to become this, and it's going to be bitwise and we want the value to be as small as possible. So we know, okay, so we have, hold a second, we can do this. Right, so this is what we want, and we have 3 numbers, right? 3 numbers. So because it's a 1, so everybody has to be 1. There's no question about it. And this is a 0, so well, you can all do 0, but you cannot. And then you have to decide how do we get it up, and everyone has to be bigger than the previous one. Right, so yeah, so we have the previous, and then we have this. Is this going to be the smallest? Well, it doesn't matter. What it says is we have a 0. We need to like have 1 0 here and 1 0 here, right? So we can say, okay, I'll put 2 0 here, and then we can do a 1 a 1. Right. Okay, so let's get another one. X is 7, so 7 is 1 1 1. Okay, and we have 2 values for this. Basically, it has to be 1, and this has to be 1. This has to be 1. So the only way is to have this. This is 7 and a 15. Huh. Okay, so based on what we have, right, based on what we have with the x, now we know every number we can have the 1s all settled, right? So all the set bit is done. And the first one, because you want it to be smaller, so you got all the zeros. And when you get all the zeros, actually it's already done, right? You already get a result. So now you just start to put, like add a 0, not add a 0, but you put a 1 in all the positions, right? Put 1 in all the positions. And based on how many positions is 0, right? If we have like say 2 positions as 0, so 1 it can be this, the other can be here, right? Actually we can have another one. So we have, yeah, depending on the number of zeros. So if I have 2, because each one has 2 options, no, because we already saw this is going to be 2 to the 2 minus 1, because I cannot have all 0 in this one already taken. So this will give you 3 options, which means you have 3 numbers you can choose from, right? And this basically has 0 zeros. So you have 0 options. So you cannot do anything. So the next one has to be add 1 to the front. All right? There's just no more options. And you cannot so what if we use up all the options? Like let's say if this one we have like 2 more numbers, right? So we already filled up everything, so you cannot get any more combination here. So what you need to do is put it on the front. Yeah, you have to put 1 in the front. There's no other way, right? But you also want it to be small. So you get the smallest possible, and then you put a 1 in front. Yeah, so in this case, we can actually do, if we have n equal to 5, right? N equal to 5. So we have this, we'll have this, we'll have this, we'll have this, but the next one is going to be like this. So that's what? 12, right? So we can actually give this a shot. So the 5, answer should be 12. Exactly. So basically, what we do in here is, well, get x, count how many zeros. Oh, does Java has this function? Oh, in binary integer. I'm actually not quite sure. I don't think so. You can count. You have a bit count. Okay, you can do a total bits and then do a bit count. I guess you can do that. Yep, you can do that. Total bits we already realized it's gonna be log 2 plus 1 is the total bits, and then you minus the bit count is gonna be the 0 count. Okay, we can do that. So now we got the number of zeros, then we know how many it can afford, right? But we need to know where they are. We need to know where they are. Can't just randomly pick them, right? But it's okay. Yeah, I think it would be easier to just get a string out. Get a string out and see how many numbers there are, right? How many numbers there are. Oh, I just realized if I have another one, then we have to keep these things the same. But here, I can do this. Right? You can just keep adding zeros. Let's see, if we do a 6 count, then what we need is 4 plus 16, that's 20. Oh, holy crap, you're right. We have a bunch of things here again. Oh, yeah, that's right. And when we exhaust, become this, right? That's when we exhaust. Then, oh, then. Because this one has to be 1. So if we say we go back to 1, 0, 0, right? And then we need to extend, so we do this. So that's what? So it's going to be 4 plus 4, 8, 9. Now we have 3 zeros to play with. Right, now it has 3 zeros. You can do whatever you want. 3 zeros, you can do whatever you want. All we need to make sure is all the ones stay the same, right? All the ones stay the same, then we have the zeros, okay? And if we exhaust all of these, we put a 1 in the front. And then we do that. And then we put another 1 in the front. Yeah, basically because there's no zeros here, right? And then we put 1 0, and then we put 2 zeros, and then we go through this. Okay. Okay, so what are we going to do? We're going to count the number of zeros, okay? And then let's see if n fits inside. If n fits inside, we can find that n, and then we know it's like combinations, right? And then we will make changes to that array. We're going to do a char array, right? So we put those positions in it, and then we do the numbers. And if it doesn't work, if it does not work, then like if and we can actually already see how many it will need, right? Because it will start with the number of zeros, 2 to that, right? And we can handle that many numbers. And then if it doesn't work, we start at 1. We start add that. Yeah, so basically we have, let's say we have y, number of zeros. So we have 2 to the y, that's the first round. And then we have, now we start putting 1, 2 to the y, and then 2 to the y plus 1, 2 to the y plus 2. So that's kind of how many we can do. So we get y. Is it good? If it's not good, we add. If it's not good, we add. So until one time it's kind of blow up, right? It blows up. And then when it blows up, we get that. So we know the number of zeros, and then we'll have it. And then we will need to coordinate the positions of everything. Because I have x, right? I have x. So I can just fill in the x, right? Fill in the x. Yeah, we need to fill in the x from the right to left, right? And then we get the final number out. Right, we get a final number out, and we fill in those as well, and then we turn that into, okay, we have an idea to do this. Let's try it. All right, so the idea is x, right? We need to know x. We need to know the number of bit counting x. So we turn, I forgot, how do we turn that? Binary string. And there is a function, integer.to binary string, right? Integer.to binary string. So we say string being x, integer.to binary string x. Okay, so we got that. And we need to count the number. So int num zeros for is a char c of being x dot to char array. Num zeros plus equal to c is equal to 0, 1, otherwise a 0. Okay, so now we know the number of zeros, right? We know the number of zeros. Okay. Then what we need to do is n, right? We need to do n. And 0, 0, and we do the first round. Oh, we just need to know, can we do this systematically? Yeah, you can do it. If one left shift num zeros is larger or equal to n, now all we want is the final thing, right? Okay, we need to know the number of zeros. We need to know the final final value, right? Let's call it temp. Okay, so if one left shift num zeros is large, so we have enough, right? Then the number is going to be n, right? The number is going to be n. Like in this case, we have n equal to 3, so the final one is going to be, because this is 4, right? This is 4, so the final one is going to be 3, which is no, 0, 1, 2. Final is going to be 2. So it's n minus 1. Final is going to be 2, right? So here is the same. So if one left shift num 0 is larger or equal to n, then temp shall equal to n minus 1, right? That's what we want. Else, then what we want to do is n minus equal to one left shift num zeros. Okay, then we'll say while n is larger than 1. Okay, hold on. Yes, left shift num zeros, right? If n is larger, so n we already reduced n, okay? So we say the remaining n, if it's larger than 1, left shift this. So this is basically, we are just adding a 1 here, so we have the same number of zeros. So we say if n is larger than that, again, then we take away, right? We take away that much num zeros, okay? And num zeros plus plus, right? Because num zero we can add, right? So we add it, we try it again, we just keep reducing until at one point n minus this, and then the next round it's going to be smaller, okay? N is going to be smaller. So n is smaller than the next one, so that will be n. Now we can say temp shall equal to n minus 1, okay? Alright, so now we drop out of this. We know the number of zeros. We know the temp, which is, it's really hard to describe what this temp is. This temp value is just when you reach the target number, it's binary representation, right? Okay, so now we can create, right? Now we can create a I want to say char array, right? Char array, but how long this char array needs to be? Now that is a very good question. I honestly do not know, and I don't really, do I really care about how long it's going to be? I don't care. I can just set up to be very long, because the answer is long, which means it's going to be 64, right? Because an int is 32 bits, right? So a long is 64. So I can just create, let's say, a char array of res new char of char. Yeah, of 64, okay? And we'll first fill in the binary x put into it. We say for int I equal to, let's say bin x. Ooh, we need to fit from right to left. That is going to be interesting. I think it's fine. Dot length minus 1. I large equal to 0. I minus minus. So what I want to do here is say res, that's not I think it's gonna be 64 minus I minus 1, right? So it's just 63 minus I shall equal to bin x dot char I. Ooh, that is not right. Let's reconsider. Let's reconsider. Yep, let's reconsider. Smaller than bin x dot length. Let's do plus plus. And I just say bin x dot length minus I minus 1. Right? So this fell from right to left, so we fill it up. And then we know the temp, so we need to get the string. Technically, we don't need to get a string because we can simply I mean, we can get a string, or we can simply using a binary operation to get, because all I want to know is where the so all the zeros need to turn into that, right? Because I know the number of zeros. So from right to left, I will go, and now we hit a 0. Then we'll check there, right? Check the first position, and then we'll check the second position, right? Every time we hit 0, until we hit the end. How do you know when we hit the end? Because we know the number of zeros, right? So we just keep going until we exhaust the number of zeros. Okay, until we exhaust the number of zeros. And when that happens, okay, I need an I. Okay, I need an I. I need a position. So I need to put a 1 there. But it also depends on whether we need to put an extra. How do we handle that? Because I do num of zeros, right? And how do I know if I need extra 1? I think I probably need to put here boolean need extra 1. Let's call it false. Okay, but you're coming here, you do need extra 1 equal to true. Okay, I can use this to decide whether we need extra 1. Alright, so you go right to left every position. If it's a 0, then you know what? In this case, I feel it's actually easier if we just do int. You know, we just do int, and this one we can just say x and 1 left shift I, right? Because we go 0, so 1 left shift I, and we'll end this, and if it's larger than 0, we'll do 1, otherwise we'll do 0. Okay, so I need to probably set us up better, right? So basically this will put 1 and zeros into the result. But in this case, why you even use a result? I think you can just say result is 0, right? And then you can say res or equal to, or you can do yeah, if it's a 1, right? If it's a 1, then you left shift. If it's a 0, you skip. Okay, we can say if right, we can say if this is larger than 0, right, 1 left shift I, then we say res or equal to 1 left shift I. Alright, this is just to copy this number in. And once we copy the number in, then we have temp, right? And then what we need to do is, again, go from right to left. And when we hit a 0 in result, we will in result, when we hit a 0, we will put that, whatever that, into it, right? And then we go, we hit another one, we put that into, so it's like kind of two indices, 2 pointers. And once one of them is exhausted, right? Once one of them is exhausted, how do you know if one of them is exhausted? Oh, we can right shift. Holy crap, we can right shift. Yeah, we shall do right shift. We can consume binary x, so we can basically say, oh, we can just do this equal to binary x. I don't know why you don't do it. You can just do binary x. We don't need to do any of this, right? This is exactly the case. We do binary x, and then we have a temp. So we go through this right to left, right? We go through this right to left, and we can say while this, and then we go right to left, find the first one, I can say while temp is larger than 0, and then while we do need an integer I equal to 0. Maybe because I need to know how many shifts we need to do, right? So we can say res and one left shift I, while this is equal to 1, under this larger than 0, I plus plus. Right, because I need to keep checking. I need to keep check to see if it's 1, we skip. But if it's a 0, right? If it's a 0, so we'll jump out. Then what do we do is we will get the rightmost bit of temp, put it into res, right? Whichever it is. So how do we do that? Well, we'll say if temp and 1 is larger than 0, which means the last bit is a 1, then we will say res or equal to 1 left shift I, because it's at I position, right? 1 left shift I, at this position we find a 0, okay? And in temp, that position is supposed to be a 1, and then we'll res or equal to 1 left shift I. That's correct. And if it's a 0, we just skip it. And once we've done that, temp will right shift 1. Right, temp will right shift 1, and then we just keep going. Because it's a right shift, eventually we will get to 0, right? We'll get to 0, and I will just keep growing, and then this one will set up all the things for the temp. Again, I think cannot cast because of course I'm not going to cast. This should be x. Operator n is undefined for argument this. Oh, wait, hold on. I think it was not right. I think should be another one here, and should be this one. Okay. So temp and 1. Okay. So once we're done here, and then we need to check if need extra 1. If we need extra 1, which means for the result we need extra 1, and where is my position? Now we have I, right? So I will go, we hit this, So at the end, right, because temp, the last one is a 1, and then so I will point into a 0, so that's a 1, we put a 1, and then temp becomes 0, so I need to plus plus, right? I need to plus plus, so we need to do 1 more plus, and we need extra 1, so we can say res shall be or equal to 1 left shift, right? 1 left shift plus plus I. I'm pretty sure plus plus has a higher order compared to left shift, so we can do that. Once we do that, we'll return res. Okay, so if that is the case, right, we don't need to, we just need num of zeros, right? If we need num of zeros, I can get num of zeros by doing int math.log x divided by math.log 2, right, and plus 1. This is the num of 0. This is a total bit, so minus integer dot bit count x, right? So we don't need this, and everybody becomes bit operation. Okay, let's try. Let's see if it works. Apparently it does not. Okay, it does not work. Let's do the easy one, see if it works. It also does not work. Now that is very bad. Okay, so system.out.println, let's do num zeros. Make sure our num zeros at least is correct. Okay, we have 2, that is correct. And 1 left shift 2 is 4, 4 is largely equal to this, so temp shall be 2, right? Temp shall be 2. We can double check on the temp here, so we say temp is 2. Good, temp is 2. All right, temp is 2, while temp is 0, and the res is gonna be this, right? Res is this. Res is 4, and res and 1 left shift 0, so it's still 1, and this is larger than 0, no, so I is 0, come down here, temp and 1, temp is 2, right? Temp is 2, so temp is 1 0, right? Temp is 1 0. This is our temp. Is it larger than 0? No. So basically we don't do anything. And oh, I think I need to plus plus no matter what. I didn't move I. Yep, you did not move I. Okay, so how do we move I? Ooh, I think we know. I think I know what is wrong. Okay, so I need to move I, which means I need to move forward every single time. So we can say if res and 1 left shift I is equal to 0. Okay, if it's equal to 0, we don't do this, and we do this. Okay, and I plus plus. I always plus plus every single time. So for this position, I check if it's a 1, we just move forward. We move forward. If it's a 0, I check temp. If temp is good, I move it, and then I move decrease the temp, right? And I will always plus plus. So every position I checked, I will plus plus. And because of that, I think here I can just do I. Okay, let's do it one more time. Okay, now this one's correct, and we have, I don't know, did we do a 9? Yeah, we did do a 9. Oh. Okay, that is pretty bad. That is pretty bad. All right, so what we're gonna do is 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's see how many is correct. All right, so it starts to go wrong. So it's 1, 2, 3, 4, 5. Okay, so 5 we have wrong at 5. Okay, these are good. So I need to put it somewhere. Because these are good things. Maybe I can do. Put it here. Okay, and then. So we got wrong on 5, right? So 5 basically we can move down. Yeah, expected 12, but I got 5. Okay, that is very stupid. Okay, that's very stupid. Number zeros will be right. Give me temp. Temp should be 3. Okay. Out the print line. Temp shall be 3. If it's not 3, ooh, temp is 0. That is very interesting. Wait, hold a second. It's 5. Number 0 is 2. So 1 left shift, that's 4. 4 larger than n, that's wrong. So n minus equal to. Oh, I see why it becomes 5. But that should still not be 5. Hold on. N minus equal to. So 1 left shift is 4. So n equal to 1. That is the case. N equal to 1, which means is 1. Huh. Temp is 0. That is correct. Temp is 0. Right? Temp is 0. Yes. And we don't do this. And we need extra 1. That is the problem. Where the extra 1 should be. Right? Where the extra 1 should be. Ooh. Yep, it cannot be relying. You cannot rely on I. That's not right. So we need to handle this. The total, the maximum bits, or the position, the leftmost position, right? The leftmost position. We can do here leftmost position. Okay. Yeah. We can do this. Int leftmost position shall start with. I don't want to calculate again, so I can say total bits equal to this, right? So we do total bits, and we say it's a total bits minus this, and this shall be total bits minus 1, right? That's the leftmost position. So for this case, total bits is 3, so leftmost position is 2, so you 1 left shift 2, right? And then, if this is fine, but otherwise, every time that we go through n minus equal to this, then leftmost position should plus 1, right? And then when we go through this, n is larger than, yeah, so if n is larger than, then we say leftmost position plus plus, right? So we take away the original. If it's larger than, then we need to move forward, right? N minus. If it's still, we just keep moving, and eventually you will get the leftmost position. And we say, actually, we don't even need this check. We just at the end, we shall say leftmost position, and that should give me the right answer. No, it's not. Jesus. Okay, I can do, how about we do this? Right, wow, n is larger than this. And if it's smaller or equal to this, that means I don't even need to do this part, right? I just do this. Then why do you need this? I don't need this. I just say n minus 1. Temp is just n minus 1. Right? I don't just say n minus minus. So this is the number. This is the largest number, right? The zeros in the 0 bits in X can form, right? You check this first, and if it's not, and then this one will plus plus and or minus, and eventually it will get to this n, and this is a temp. You don't need temp. It just n. It just n, just n, just n. Let's try this one. Okay, this one's correct, and let's go back to here. We have all of these. Let's throw all of them at it. Let's see if it's correct. Nope, it's not. Which one is wrong? The last one. Okay, the last one. Okay, no problem. Let's get the last one. So basically we handled them. So now we need to move 1 position more. Right, 1 position more. And I got 12, but it should be 20, which means, oh, let me think. So it's 9, right? And I can afford this 4. So 9. And the standard output is 4. Standard output is 4. The n is 4. The n should be 0. So n larger than one left shift, n or minus equal to that. So n is 9, number 0 is 2, so it's 4. 9 larger than 4, yes. So 9 minus 4, n become 5, right? N become 5. A leftmost position will move to here. Num zeros plus plus. That is not right. That is not right. We do have to do it two ways, unfortunately. Because, yeah, this is kind of two different ways. Okay, so we do have to do, let's say, if n is smaller or equal to one left shift num zeros. Okay. No, I think you should say if n is larger than. Put this inside. Right, because if n is smaller or equal to, you directly do this. That's fine. If n is larger than, then you have to do this. N minus equal to 1 left shift num zeros. Do that first, right? And that is your starting point. And then you have to do left. So yeah, so you minus a first, right? And you do. But why would this one still be not right? Yeah, the problem here is I didn't do the leftmost position plus enough, because I start with n is 9, okay, and so left plus plus, n minus 4 becomes 5, right? And then, wait, hold on. Hold a second. Let's go back to this. And what's leftmost position? What's the leftmost position? So leftmost position 0, 1, 2, 3. Leftmost position is 3. And we start, n is 9. 9 larger than 4. So this already becomes 3, right? And 9 minus equal to 4 is 5, right? And this become 3. That's the one. That is the one. The first time you don't increment. Got it. Yep, you are right. We have to do it two ways. So if n is larger than one left shift num zeros. Okay. If n is larger than this, right, then we have to handle the first one, because the first one does not increment the num zeros. That's the one. Yes, the first one does not. So n minus equal to 1 left shift num zeros, right? And then we say leftmost position plus plus, right? Then we run this. Okay, then we run this. Then we run this. And once we're done, we come out here, and then we try it. Now it's right. Okay? Okay, let's do this, Comment out both. Try one more time. Now we got everything right. We also have this 2, 7 thing. It's actually a very good test case. Let's try this 2, 7. 3, 7. 4, 7, 5, 7, 6, 7, 7, 7, 8, 7, 9, 7. I have no idea, but just throw some at it. See if this one can handle it well. Okay, I think now I have pretty much confidence that this shall work. Let's copy it back and hope it does work because we took a long time on this. I mean, again, I don't think this is like difficult, but it's just how should I put it? It's very complex. Quite a lot of thinking. 3, 1, 3, 3, right? So first, find out the number of 0 bits in X, right? And then say there are 3, right, 0 bits. Then the then these 0 bits will go from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, right? We'll go from this all the way to this, right? This order, right, will be used to also while keeping the set bits of X intact, we will use this order to fill in the 0 bits for each number in the array in order. Now if n is larger than 1 left shift num zeros, then we need to append 1 append bit to the left of append set bit to the left of X, right? So the first set bit will have no zeros, no 0 between it and the leftmost bit of X. The second set, right, if that is still not enough to fill out n, we will move the set bit. Move the set bit. We'll move the set bit to the left, right? And try again. Until we hit N. I just realized we can use that. So I got num0, so I got a total bits, right? We do need N. Yeah, it's fine. Yeah, we have to do this. We get the leftmost. Okay, yeah. So I think this should be right. Let's try it. Hopefully it is right. Because if it's not, then why is it so slow? These are fine. This is rest is already long. I is integer. So do I need to put I as, or maybe I need to put this as a long? N is fine. The rest should be fine. Okay. This is like a overflow issue. Nope. Ugh. Man. Thought it was right. I have no idea. I don't know what went wrong. What's the binary of these two? Let's see. Expected this. Ooh. Long. Number too large. What? Number too large. How come is number too large? It is long, right? And remember, Java doesn't have long, right? Java does not have long. But why is it it's integer number too large? Huh?
I don't understand. What's long? Oh, this is very, very discouraging.
It's probably just J shell issue. I don't understand. I have no clue. Let's go Python. Okay. How about this one? Should put one more. Oh, maybe. Yeah, there we go. There we go. Damn. Wow, it's took a lot of efforts. A lot of efforts, honestly. My goodness. Have to go. Man, sometimes is I think it's the J shell issue. I'm not 100% sure, but well, we got it. We got it. Just using these strongly typed language. This is the thing that will happen. I mean, you got the algorithm right, but at the end, I forgot where I should put long, where I should just Python is so much easier to do this. I think it's pretty good. We probably got it, but Jesus, man. I have I have no idea. Oh. Oh, Python will TLE, they say. ON. Ooh, 10 to the 8th. Yeah, 10 to the 8th even TLE. Not only Python, I think they are all. Okay, I need to read this. I don't know. Bit manipulation. Well, I think we are a bit masked with logical operations. Log n. Mine is log n, right? It's all log n. Ooh, look at that. Look at that. Okay. Huh. I think it's the same idea, but this is so much easier. Alright, I'll give it some thought. I'll leave it here. I'll leave it here for now, because I really have to eat. Okay, I will see you guys tomorrow. Good question. I think it's a good question. I like it. Adios.